Hello everybody, today we're going to be talking about the dot product. So the dot product of two vectors, or the scalar product, is defined as some vector A. By the way, we're going to just underline the letter A to show it's a vector. So some vector A times another vector B equals the magnitude of the vector A times by the magnitude of the vector B, and that is being multiplied by the cosine of theta. By the way, theta is the angle between U and V. So say A and B. So you have a vector going this way. This is A, another vector B. So it's the angle between their initial points. Okay, these are their initial points, and this should be theta here. Okay, and theta, our angle, is always between 0 and pi. Or if you want to use degrees, it's between, including 0 and including pi. So if you want to use degrees, it's between 0 degrees and including 0 degrees and 180 degrees. So if we add two vectors, say like this, A and B, our angle would be here, but our angle would not be here, because this is larger than pi, or 180 degrees. Let's do another example. So say we had two vectors like this. I'm not going to even bother labeling them. Theta would be here. Okay, our angle would be here, not here. Okay, so I think you get the gist of it. So now we are going to also prove another result of the dot product, and that's that A times B, the vector A times the vector B, is equal to AX BX plus AY times BY plus AZ times B sub Z. And by the way, our vectors here are just going to be described as, so A is going to be AX times the unit vector I plus A plus AY times the unit vector J. That's a terrible A. There we go. Plus A sub Z times the unit vector K. Okay, and likewise for B, it's going to be BX, so B sub X times the unit vector I plus B sub Y times J plus B sub Z times K. And these A's here, all of these A's, likewise all of these B's, these are just coefficients multiplied by their corresponding unit vectors. And what are the unit vectors? Well, so say you have your X and your Y and your Z plane. Okay, the unit vector I is just like this. Okay, the unit vector J is as shown, and the unit vector K is like this. So they all have a direction, but their magnitude is always 1. Okay, So the magnitude is 1 for all I, j and k. So now let's just go into the proof of this. So we're going to say proof. Well, a times b is going to be equal to axi plus, a sub y j plus a sub z k multiplied by b sub xi plus b sub yj plus b sub z k. Now we can multiply this out and we get ax bx times I. We're actually going to put the unit vectors in the front. Okay, we're allowed to do that, so we've just gone axi times bxi. Then it's going to be plus axi again. We're going to put the I in the front, so we get axi times by byj, so it's going to be ax times b sub y times I times j. And then it's going to be plus a sub x b sub z I times k. And on to the next one. Now we're multiplying b, so then it's going to be plus we're multiplying a sub y, so it's a sub y times b sub x, and it's going to be j times I plus, and it's still a sub y, but now we're multiplying by b sub y times j and times j plus, and for this one it's going to be a sub y again multiplied by b sub z this time times by j and times by k. Okay, so now I have 3 more. We just have a sub z times by b sub x times k times I plus a sub z times by b sub y times k times j, and finally plus, it's going to be a sub z times b sub z times k and times k. Now if we're multiplying two unit vectors, say I times I, well, if we look on here, of course the angle between them is going to be 0, but by our definition of the dot product it's going to be the magnitude of these two, which we know is 1 because they're unit vectors, so it's going to be 1 times 1 times 1, because the cosine of 0 is just going to be 1, okay? So I times I is 1, likewise j times j is going to be 1 because the angle between j and j is 0 again, so you get the gist. But what if we do, say, I times k? What's going to be the magnitude? 1 times the cosine. What's the angle? Well, as you can see, the angle is pi over 2, or 90 degrees. So let's write it in degrees. So it's 90 degrees, but the cosine of 90 degrees is 0. So this will be 0. And more generally, when you have perpendicular vectors, when you have perpendicular unit vectors, like we do here, so when you have two different unit vectors multiplied together, they're going to be perpendicular, and hence their angle is 90 degrees, so the cosine of their angle is always going to give you 0. So from this we've concluded that multiplying two different unit vectors will always give you 0. Let's say I times j is going to give you 0, k times j is going to give you 0, but multiplying two of the same unit vectors, I times I, will always give you 1, j times j, 1, likewise with k. Okay, so now we can just apply this to our proof over here. Okay, so from this we get that, well, ax, well, this is going to equal ax bx, because we have two of the same unit vectors, I times I, but here we have I times j, that's going to be 0, so we can ignore that. I times k, let's ignore that, because they're different, they're perpendicular, so they equal 0. J times I, get rid of that. J times k, let's get rid of that. K times j, we can get rid of that as well, and k times I. So we're left with ax bx times I plus ay, a sub y, b sub y times j plus a sub z and b sub z times by k times by k again. So concluding, this equals ax bx, because this equals 1, this equals 1, and this equals 1 as we showed earlier, plus a sub y, b sub y, plus a sub z, b sub z. And yeah, that's the end of the proof. So we've gotten the result we wanted, which is a times the unit vector, sorry, not the unit vectors, just some vectors, a times b. The dot product of them is ax bx plus a sub y, b sub y plus a sub z, b sub z. So very nice. Now we're actually going to apply this. Oh, did not mean that. So we're going to apply this new knowledge we have. So let's say find, let's zoom in a bit. So find the angle, between u, well, u's just a vector, and v. Okay, very nice. Now we actually do have to define these vectors, of course, so we're going to say u, no, let's do this in red. We're going to say u equals, let's say 2i minus j plus k, and v is going to be I plus j plus k. Let's do 2k. Sorry, let's do 2k. Okay, very nice. So to find the angle between u and v, first of all, let's just write down what we know. So solution. Well, let's write down the formulas which are going to be helpful. Well, of course, we're going to have to use that cosine theta equals, where we know a times b, a dot b, sorry, is equal to the magnitude of a times magnitude of b times cosine theta. So then cosine theta, if we just divide by the magnitudes, we get that cosine theta equals a times b, but sorry, we're using u and v, so let's do that. U, so we get cosine theta equals u dot v divided by the magnitude of u times the magnitude of v. Okay, that's very nice. But we also know that u times v equals u sub x v sub x plus u sub y v sub y plus u sub z and v sub z. Okay, so let's apply these formulas now. So first of all, let's work out u times v. So u, let's not do it in green, let's carry on in blue. So u times v is going to be ux times vx, which is 2. So it's 2 times by 1, because the coefficient of I is 1. Then it's going to be plus, let's write it all in blue. So it's going to be 2 times 1 plus negative 1 times by 1 plus 1 times 2. Okay, very nice. We can simplify this down a bit. We get 2 minus 1 plus 2, which of course equals 3. So u times v is 3. We also need to know the magnitude of the vectors. Okay? So the magnitude of u is going to be, and this is how we find the magnitude, it is 2 squared, okay, 2 squared, put that in brackets, 2 squared plus minus 1 squared plus 1 squared, and square root all of that. So of course this is going to be the square root of 2 squared is 4, minus 1 squared is 1, and 1 squared is 1. So this equals the square root of 6. So that's the magnitude of u. What about v? Well, for v, the magnitude of v, let's put those there. This is going to be, well, it's going to be the square root again, but it's going to be of 1 squared plus 1 squared plus 2 squared plus 1 squared and plus 2 squared. Okay, very nice. This is going to be the square root of 1 plus 1 plus 4, which equals square root of 6 again. So now the cosine of theta is going to be 3 divided by 6, because we're doing square root of 6 times square root of 6, which equals 1/2. Therefore theta is going to be none other than pi over 3. That's a pi, or 60 degrees. So pi over 3 radians, or 60 degrees. And that is the angle between the two vectors. So I hope you enjoyed today's video. Quite a long one, but we did a lot. We explained the dot product, we did a little proof of the theorem, and we did an example. So yeah, hope you enjoyed today's video. If you did, leave a like and subscribe, and goodbye.